So this is the last part of inverses for us. So today we're going to be talking about a lot about the graphing and why the equations are the way that they are and what extra things do we have to start adding to those equations so that they are fully the inverse and why that is. So the first thing I have this equation, f of x equals x minus 2 squared plus 1. So the first thing I want to talk about is looking at that one's domain and range. Domain, how far left and how far right. That is going forever left and forever right. So my domain is all real numbers. And we're looking at the graph that's there. Range, you're going from low to high. So how low is this going? Is 1. And how high is it going is infinity. And since 1 is included, it's got a solid dot, it's including, it's not an open dot, 1 is going to get a bracket, and infinities are always going to get parentheses. So there is really 3 things that I really want you to remember about inverses. The first thing is that your x and your y are going to flip. That is the basic of what an inverse is that you are flipping your x and your y. We did that when we solved them algebraically, so we're going to do the same thing even if you have ordered pairs. That's just what an inverse is. They are flipping the x and the y. If you're flipping the x and the y, then you're flipping everything that x and y control. X controls domain, range, y controls range. So therefore your domain and your range are also going to flip. There's one other thing that's going to pop up here on the screen that is important about inverses, that it is reflecting across the line y equals x. It's not reflecting across an axis, it's reflecting across the line, for y'all, y equals x. Okay, so those 3 important things to remember about inverses. So I'm going to graph the inverse. So in order to graph the inverse, I need the original ordered pairs. So I'm going to pick some of those ordered pairs. I'm going to pick that ordered pair at the y-intercept. I'm going to pick the ordered pair 0, 5. Another nice point is at 1, 2. 2 1's there for me. It's already on there. So 2, 1. And then 3, 2 looks pretty good. And then 4, 5 is going to be that last really good ordered pair. So that's my original table. Now to graph the inverse, remember step 1, what does an inverse do? An inverse flips your x and your y. So my first ordered pair is 5, 0, then 2, 1, 1, 2, 2, 3, and 5, 4. So now I am going to graph those. And so what you'll notice is it looks still like a parabola. It's now just a parabola turned sideways. Now I can now use that graph to give me my domain and my range, or I could have done my domain and range before I even graphed it, because looking at that second statement, your domain and your range flip. So that means my inverse domain is now 1 to infinity. If you look at my graph, that's what it does. It's going as far left as 1 and it's going as far right as infinity. My inverse range is all real numbers. It's going forever up and forever down. So without even graphing it, don't we love math that we don't even have to do like really math for? Without even graphing it, I could give my domain and my range because all I had to do was flip it. My domain becomes my range becomes my domain. As long as I have the original, I can get that information. Now let's talk about finding the inverse algebraically. We just spent a whole class period talking about that. So let's talk about how to find this one algebraically and see how that fits in with that graph that's up there. So I'm going to go ahead and rewrite f of x as y as my first step. So y equals x minus 2 squared plus 1. Flip your x and your y, because that's what an inverse does, is you flip your x and your y. So x equals y minus 2 squared plus 1. Got to get y by itself. So I'm going to subtract 1 on both sides. So I have x minus 1 is equal to y minus 2 in parentheses squared. Now what's farthest away from the y is that squared. How do you undo a squared? You take the square root. So take the square root of both sides. So I have the square root of x minus 1 is equal to y minus 2. Last thing to do to get y by itself is you add 2. And I'm kind of out of room, so I have y equals the square root of x minus 1 and then plus 2 outside of it. f inverse of x is equal to x minus 1, and then plus 2 is outside. But if you look at that graph, that is a square root graph. A square root graph with a vertex of opposite h, keep the k. So that has a vertex of 1, 2. If you look at my graph up there in the red, because the red's the inverse, red's what we're talking about. I have a square root graph that starts at 1, 2, but that's just the positive side. So what I need is an equation that has that positive and the negative one. So I need a square root that's going up, and I need a square root is going down. So that is why, so there's the one that I need, the one that's down. That is why we put a plus or a minus in front of that square root, because I have the positive square root and I have the negative square root. That way I have that full parabola looking graph that fits my domain and my range of my inverse. So big picture idea. Hope you're like, oh, now I get it. Big thing to remember is with a quadratic, you must put a plus or minus in front of the square root. Very, very important for you to remember to put a plus or minus in front of the square root if your final answer has a square root. So if your final answer has a square root, it's because you started as a quadratic. Now let's talk about what happens when we start with a square root graph and how that affects our graphs, how that affects our equations that we end up with in the end. So looking at this first graph, I have the equations there. It has a vertex of negative 1, 1, which it does, goes over. Okay. This one has a domain of negative 1 to infinity, that's opposite h. It also has a range of 1 to infinity because it's k to infinity. Without even graphing it, I know what my inverse domain and range are. My inverse domain is going to be 1 to infinity, and my inverse range is going to be negative infinity to 1. Just because everything flips. My x's and my y's, they flip. So it was very easy. No math, really, no, maybe a little thinking, but no really like math, calculating, that's the word. No calculation is involved in this type of question. Now, I do want to graph my inverse. So to graph my inverse, I need some ordered pairs of my original. So I'm going to make a table of my originals. So I have the ordered pair, and then I label them so that I don't get confused. So I have the ordered pair negative 1, 1. I have the ordered pair 3, 3. And I have the ordered pair 8, 4. All you really need is 3 points. So now let's do an inverse of that. So an inverse of that is going to be 1, negative 1. 3, 3 again. And 4, 8. So now let's go ahead and graph that. I have 1, negative 1, 3, 3, which was already there, and 4, 8. And if you look at that graph, what is that graph besides it looks like a square root? I get that. It looks like a square root. But what does that graph almost look like? It almost looks like a parabola, but it's like cut in half. So keep that in mind for just a second while we talk about finding the inverse equation. I'm going to go ahead and rewrite f of x as y. So y equals the square root of x plus 1 plus 1. Switch your x and your y. Then to get y by itself, what's farthest away from the y is that plus 1. So to get rid of it, you subtract 1 from both sides. So you get x minus 1 is equal to the square root of y plus 1. Now, I can't touch that plus 1 that's inside because it's under the hut. Got to get rid of the hut, so you square both sides. Parentheses are important. So you have x minus 1 squared is equal to y plus 1. Last thing to do is to subtract the 1 from both sides. So you have x minus 1 squared, and then minus 1 outside is equal to y, which you can change to f inverse. But that graph is a quadratic. Because it's got a squared, it's a quadratic. Quadratics make full parabolas. So what I've done now is I've drawn that half of the parabola so you can see that that's what that graph would have been. It has a vertex of 1, negative 1, which that one does, okay? And then it goes up from there because it's a positive, your a is positive, so it opens up. But if you look, my green graph doesn't have that. My green graph is just the right-hand side. So what you have to do if you are starting with the square root, you have to write that domain at the end. That's it. That's just simply stating that you're only going from this x to that, to the end. So this side, you're only doing the right-hand side. So you have x minus 1 squared minus 1, f inverse, and then you just add that domain to it. Okay, you already found the domain because it's the inverse of the original, and then you just add it to the end. That's it. That's the only thing that has to get added to the square root. So if you are starting with the square root and finishing with a quadratic, you just have to put the domain at the end. Okay, another example, this one is reflected because it's opening down. So this one has a domain of, and the graph's there, it's opening down because your a is negative. Let's just recap everything. So it's opening down, it's reflected because your a is negative. It has a vertex of 2, 3, opposite h, keep the k. So my domain on this one is h to infinity. So my domain is 2 to infinity. Because it's reflected, because I have a negative, because it's reflected, and when you look at the graph, my range is going from negative infinity to 3. 3 getting a bracket. Without doing any math, without doing any calculations, I know that my inverse domain is that flipped around. So my inverse range is my inverse domain is negative infinity to 3, and my inverse range is 2 to infinity. So now let's get some points together, and let's graph the inverse. So I make a XY table of my original. So my original is 2, 3, 6, 1, and 11, 0. All you need is 3 points though, so even if you only had those 3, it'd be fine. I just made it more fancy. So you flip those. So you're going to 3, 2, 6, 1, and 0, 11. So I'm going to graph those. I have 3, 2, 6, 1, and now I'm going to add that last point. All right, so those points. Again, it looks like a quadratic. It just looks like the left-hand side of the quadratic. So, and it fits my domain and my range. It goes from negative infinity, as far left as negative infinity. It stops at 3. It's going from 2 up. Okay, so it fits my domain and my range. Now let's find my inverse equation algebraically. So I'm going to rewrite it as y. So y equals a negative square root of x minus 2 plus 3. Switch your x and your y. Then you have to ask yourself, what is farthest away from the y? And I've kind of already started it. The thing farthest away from the y is that plus 3. So you're going to subtract 3 from both sides. So you get x minus 3 is equal to the negative square root of y minus 2. Get rid of that negative, you divide by negative 1. So that is negative x. So you have negative x plus 3 is equal to the square root of y minus 2. Okay, dividing by negative is just going to change all your signs. Then to get rid of the square root, you square both sides because I can't touch that 2 because it's in the hut. Square both sides, so I have negative x plus 3 squared is equal to y minus 2. And then the last thing to do is add 2 to both sides. So you have negative x plus 3 squared plus 2 is equal to y. But I do still have a parabola. I have a squared. I have a parabola. So I need to put a domain restriction on it. I just need to write my domain at the end. So I have negative x plus 3 squared plus 2, and then just add that domain restriction. That domain is saying I only want the left-hand side. I want from negative infinity to 3. So big picture idea, if you start with a square root, you must put a domain restriction on the equation. That just means you write the domain at the end. We already had the domain because we do the domain as soon as we find the original inverse domain and range, and we flip it, and that's it.